A very good morning to all the viewers. Today in physics, we will study some numerical problems on electrostatics. In electrostatics, you have studied about Coulomb's law, Gauss law, electric field and electric potential. Then you have studied about capacitance, pollution and so on. So, we will be discussing some numericals on Coulomb's law, certain numericals on Gauss law, then how you can find out the electric field and how capacitors are combined together, that is combination of capacitors. So, numericals relating to the combinations like in series and parallel combinations. First of all, let us revise what is Coulomb's law. You have studied that if there are 2 point charges, say Q1 and Q2, separated by a certain distance r apart, then the force between the two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between the 2 point charges. So, Coulomb's law gives you the electric force between any 2 point charges. When we use point word here, means Coulomb's law is valid only if the charges they are point charges. And you also see that it follows inverse square law. In the formula, that is F equal to K Q1 Q2 by R square. K is Coulomb's constant given by 1 by 4 pi epsilon naught. If you calculate the value, it comes out to be 9 into 10 the power 9 Newton meter square per Coulomb square. Q1 is charge on some body, on any object, say of mass 1. Q2 is charge on another point object. R is the distance between the two charges. Now, we can show that electric force is much stronger than the gravitational force. First of all, let us say you have got two charges, they are separated by a distance r and have a force F on each other. So, these are the two charges Q1 and Q2. They exert forces F on each other. Remember that the force exerted by one on the second charge is equal and opposite to the force exerted on charge 2 by 1 separated by distance r. The formula that you will use is F equal to K Q1 Q2 by R square. Now, if you double the distance between the two charges, that is if R is doubled, denominator double हो गया. So, R becomes 2R, 2R the whole square becomes 4R square. This means in the denominator you get a factor of 4. So, your force becomes 1/4 of the force that was present initially. If Q1 is doubled, अगर कोई भी चार्ज डबल कर देता जावे तो फोर्स की हो जाएगा डबल हो जाएगा. If both Q1 and Q2 are doubled, अगर दोनों डबल कर देते जान and R is halved, denominator is halved, Q1 has become 2 Q1, Q2 has become 2 Q2, so 2 into 2 becomes 4. R is 1 by 2 R, 1 by 2 R square means 1 by 4 R square. So, denominator ਦੇ ਵਿੱਚੋਂ 4 ਉੱਪਰ ਚਲਾ ਜਾਏਗਾ, 4 into 4 will give you 16. So, then the force is 16 times the initial force that was present between the two charges. Now, this is an example which will compare electrostatic force and gravitational force. The problem reads, there are two 40 gram masses, each with a charge of 3 microcoulomb, and these two masses they are separated by say 15 centimeters. You have to compare the gravitational force between the two masses to the electric force between the two masses. So, you have got two masses, both are of 40 gram and charge on both of them is 3 microcoulomb. Separation between the two is 50 centimeter. So, what will be the force? Gravitational force? It is G into m1 m2 by r square. What is the value of G? 6.67 into 10 to the power minus 11. Masses were of 40 gram each. 40 gram means 0.04 kilogram. So, दोनों ही 0.04 kilogram दे हन. R is the distance between the two. Distance was 50 centimeter, means 0.5 meter. We use SI system of units. If you find out the value, if you do these calculations, the result given is 4.27 into 10 to the power minus 13 newtons. So, this is how you calculate gravitational force. To calculate electrostatic force, we use Coulomb's law. According to Coulomb's law, electrostatic force is given by K into Q1 Q2 by R square. What is K? We had already done in the last example. K is equal to 9 into 10 to the power 9. Charges are of 3 microcoulomb each. Microcoulomb nu coulomb de vich convert karo. It becomes 10 to the power minus 6 coulomb. So, 3 into 10 to the power minus 6, Q2 is 3 into 10 to the power minus 6 divided by 0.5 square. This gives you 0.324 Newton. So, if you compare the two, you see that electrostatic force is 10 to the power 12 times that of the gravitational force. It is much greater than the gravitational force, 10 to the power 12 times in this example. Another example. The example reads, find the force between two alpha particles separated by a distance of 3.2 Fermi in air. So, you have two alpha particles here. Alpha particles means that charge on each is 2e. पहले अल्फा पार्टिकल थे भी 2e, दूसरी थे भी 2e. Distance between the two, as the problem reads, is 3.2 Fermi. And remember, 1 Fermi is equal to 10 to the power minus 15 meters. So, the distance becomes 3.2 into 10 to the power minus 15 meters. As these are alpha particles, charge on an alpha particle is 2e. So, the formula, that is Coulomb's law, reads that electrostatic force is given by Q1 Q2 upon 4 pi epsilon naught r square. दोनों charges the value same है 2e. Q1 is 2e and Q2 is also 2e. So, 2e into 2e becomes 4e square. 1 by 4 pi epsilon naught, you know it is 9 into 10 to the power 9. Charge on an electron is 1.6 into 10 to the power minus 19 coulombs. There are 2 electrons here. So, E square means 1.6 into 10 to the power minus 19 square. 2 into 2 gives you 4. Distance between the two alpha particles is 3.2 into 10 to the power minus 15. So, the value has been written here for the distance between the two alpha particles, that is 3.2 into 10 to the power minus 15 whole square. So, if you make the calculations, 1.6 square into 9 into 9 into 10 to the power minus 38 plus 9 gives you 10 to the power minus 29 divided by 3.2 square और 10 to the power minus 15 the square करोगे 10 to the power minus 30. Then you take 10 to the power minus 30 from denominator into numerator. 30 minus 29 gives you 10 to the power 1. 1.6 3.2. 1.6 cancels with 3.2 as 1 by 2. So, 1 by 2 square gives you 4. 9 into 4 into 10 to the power 1 by 4. 4 cancels out. You get the electrostatic force between the two alpha particles to be 90 newtons. Next example, what is the electric field intensity at a point P, a distance of 3 meter from a negative charge of minus 8 nanocoulomb. So, you have a charge of minus 8 nanocoulomb. You want to find out electric field intensity at this point P. You know how to calculate electric field intensity. We imagine that a unit positive charge is placed at this point. Imagine कीजिए कि इथे एक unit positive charge पे है. So, as it is a unit positive charge, it will be attracted towards minus q. So, electric field here will be towards the charge shown by this green arrow. First, find the magnitude. Electric field is given by q upon 4 pi epsilon naught r square. 1 by 4 pi epsilon naught gives you, the value to be 9 into 10 to the power 9. Charge is 8 nanocoulomb. Nano means 10 to the power minus 9 divided by distance square. R here between the point charge and the point P is 3 meters. So, 3 square. 3 square is 9, 9 and 9 cancelled out, 10 to the power 9, 10 to the power minus 9, 9 minus 9 0, 10 to the power 0 gives you 1. So, your answer comes out to be 8 Newton per Coulomb. So, electric field intensity at point P due to this charge of 8 nanocoulomb is 8 Newton Coulomb. Direction is the same as the force on a positive charge. जिधर ਨੂੰ force होएगा, force किधर ਨੂੰ लगेगा इत्थे I told you unit positive charge रखिए, this is negative charge. So, the unit positive charge will be attracted towards this. So, electric field ਦੀ direction जिधर ਨੂੰ force ਦੀ direction है उसे ਵੱਲ ਨੂੰ होएगी, that is towards minus q. So, electric field is 8 newtons. You will write it like this, that electric field intensity at point P is 8 newtons towards minus q charge. Another numerical problem. There are 3 charged objects. They are placed as is being shown here, minus 5 microcoulomb at a distance of 20 centimeter from 5 microcoulomb, minus 4 microcoulomb at a distance of 20 centimeter from 5 microcoulomb. You want to find out the force on the object with the charge of minus 4 microcoulomb. ਸਾਡੇ ਕੋਲੇ 3 ਚਾਰजेस ਹਨ, ਇੱਕ minus 5 microcoulomb, plus 5 microcoulomb और minus 4 microcoulomb. ਅਸੀਂ ਇਸ ਦੇ ਉੱਪਰ force ਲੱਭਣਾ ਚਾਹੁੰਦੇ ਹਾਂ ਇਹਨਾਂ 2 ਚਾਰजेस ਕਾਰਨ. Distance between these two and between these two is same, that is 20 centimeter. This is a right angle triangle. These angles are of 45 degrees. Then you can calculate the hypotenuse, height square plus base square. 20 square plus 20 square, the square root gives you the hypotenuse by using Pythagoras theorem, and you get it to be 28 centimeters. This is a negative charge here, minus 4 microcoulomb है charge. Here you have 5 microcoulomb charge. So, the force on minus 4 will be towards the 5 microcoulomb. 5 microcoulomb point charge करके जो minus 4 microcoulomb दे उत्ते force होएगा किधर ਨੂੰ directed होएगा towards 5 microcoulomb. ये minus the charge है negative 5 microcoulomb. ये भी negative है. So, force due to this negative on this negative will be away from it. That is from -5 to -4 like this. This is your force F2. ਪੋਜ਼ਿਟਿਵ ਚਾਰਜ ਨੈਗੇਟਿਵ ਚਾਰਜ ਨੂੰ ਅਟਰੈਕਟ ਕਰੇਗਾ ਤਾਂ ਫੋਰਸ F1 ਡਾਇਰੈਕਸ਼ਨ ਦੇ ਵਿੱਚ ਸ਼ੋ ਹੋਏਗਾ, -5 ਵਾਲਾ ਚਾਰਜ -4 ਨੂੰ ਰਿਪੈਲ ਕਰੇਗਾ, the force F2 will be in this direction. You know the formula to calculate the force, electrostatic force, that is K Q1 Q2 upon R square. You can find out the magnitude. F1 K you know is 9 into 10 to the power 9. This charge is of 5 microcoulomb, micro means 10 to the power -6. This charge is 4 microcoulomb, 4 into 10 to the power -6. Distance between the two charges is 0.2 because it is 20 centimeters. 20 centimeters means 20 by 100 meters, 0.2 meter. So, इस distance the square है 0.2 the square. If you make these calculations, your answer will come out to be 4.5 newtons. So, force F1 is 4.5 Newton. Then you calculate force F2. Now, this distance between -5 and -4 we have already calculated it to be 28 centimeters. 28 centimeter है distance. So, here R will be 28 centimeters. How many meters? 0.28 meters. Formula remaining the same. You get K here as 9 into 10 to the power 9. That is the standard value of 1 over 4 pi epsilon naught. Charges are same 5 and 4 because we are calculating magnitude here. So, we are not concerned whether it is a negative charge or a positive charge, but the distance has increased. We had done in the first example that if distance increases, force decreases. So, here force decreases, F2 is lesser than F1. So, F1 and F2 these are the two forces. Now, you want to find out the net force on the charge of -4 microcoulomb. So, जो ये object है इससे net force find out करना है. What will you have to do? You will have to use vector method. या तो parallelogram लगा दीजिए, vector addition of parallelogram by parallelogram method, parallelogram law, that is F1 square plus F2 square plus 2 F1 F2 cos theta the under root. What will be this angle? 135 degrees. Or else there is another method that you calculate the components of both the forces. Now, here F1 has only one component, F2 the components निकाल लीजिए, add the components separately, then square and add both the components that have been added and take the square root. Let us see how to do it. This is the F1 force, this is your F2 force. As I told you this angle is 135, so this angle will be 45. F2 ਦੇ ਕੰਪੋਨੈਂਟ ਬਣਾਉਣ ਜਾ ਰਹੇ ਹਾਂ ਅਸੀਂ, ਇੱਕ ਕੰਪੋਨੈਂਟ ਇੱਧਰ ਨੂੰ ਰੈਡ ਲਾਈਨ ਨਾਲ, this is the base divided by hypotenuse is cos theta. So, this component is equal to F2 cos 45. This component will be F2 sin 45. F2 is 2.3, 2.3 cos 45, cos 45 you know is 1 by under root 2. So, if you make the calculations it comes out to be 1.6. This component as I told you is 2.3 sin theta. Theta here is 45. Now, you know sin 45 and cos 45 have the same value, that is 1 by under root 2. So, this component is 1.6. So, I have divided force F2 into two components. One is horizontal component which is opposite to F1, one is vertical component which is perpendicular to F1. I will draw it again here. So, as I told you I have got two components, F1 has x component as -4.5, y component is 0, y component है ही नहीं F1 का, x axis the negative direction है. F2 has both x axis करनी नो positive 1.6 और y axis करनी नो negative component minus 1.6. Now, I will show you how to add these components. So, this will be the net result. Let us see how you get it. How minus 2.9? देखिए x component is minus 4.5, this is 1.6, minus 4.5 plus 1.6 will give you minus 2.9. 5 minus 6 is 9, 5 means 15, you have taken 1 carry from 4, 3 minus 1 gives you 2. And this is 0 minus 1.6, so this component is minus 1.6. Add कर दीजिए दोनों ਨੂੰ. Minus 4.5 plus 1.6 will give you minus 2.9, 0 plus minus 1.6 will give you minus 1.6. So, x component कितना रह गया? Minus 2.9. And what about y component? Minus 1.6. Then, what is the net force? X component square plus y component square, and then you take the under root of it. X component is 2.9, y component is 1.6, 2.9 नु square कीजिए, 1.6 नु square कीजिए, you add both of these, take the square root, you will get the answer to be 3.31 newtons. So, this component is 3.31. Which law of addition of vectors we have used? We have used triangle law of addition of vectors. You can also use parallelogram law of addition of vectors by f1 square plus f2 square plus 2f1 f2 cos 135, and then you take the square root of that. Now, we can also find out the direction of this vector. जो net force है किधर directed है. So, tan theta will be equal to minus 1.6 by minus 2.9. So, you can find out theta as tan inverse of minus 1.6 by minus 2.9. If you make the calculations and use log tables, you will get the angle to be 29 degrees. So, this is how you can find out the net force on any charge due to other two charges. So, we use vector addition here. So, the net force that acts on it is 3.31 Newton in a direction that is 29 degrees. Next problem. Two 8-gram equally charged balls are suspended on earth as shown in the diagram. Find the charge on each ball. There are two balls, they have been charged, their mass is 8 grams. दोनों ਨੂੰ same charge ਦਿੱਤਾ ਹੈ, दोनों एक दूसरे ਨੂੰ repel करनी है. So, the balls will be lying like this. Now, it is shown that they get separated by an angle of 20 degrees. You know the formula for calculating force. This distance is say r. Draw a perpendicular line here, then these angles will become 10 degree each. Total angle is 20 degrees, vertical तो दोनों balls 10 degree ते हैं. This means what will be this length then? देखिए, this is 10 degrees. This length is opposite to your angle. So, this length divided by hypotenuse gives you sin theta. So, this length is 30 sin 10 degrees because angle is 10 degrees in this triangle. So, total distance will become twice of 30 sin 10 degrees. It comes out to be 10.4 centimeters. So, distance between the two charged balls is 10.4 centimeters. Now, let us draw the force diagram for any one of the charges and consider that this charge is in equilibrium. किड़े-किड़े forces लगणगे? Weight of the body, weight of the object, Fg equal to 0.08 Newton. Then this charged ball is tied with a thread, tension in the thread, and then electrostatic force Fe. You can divide the tension into its rectangular components, two rectangular components, horizontal and vertical. Because that total angle was 20 degrees, so this angle is 80 degrees. Height divided by hypotenuse gives you sin theta. So, this vertical component is t sin 80 degrees, horizontal component you know is t cos 80 degrees. These are the two. Now, if you see these, Fg is being balanced by t sin 80 degrees, Fe is being balanced by t cos 80 degrees. तो ये लाइन ड्रॉ की थी ने सिंगल लाइन showing the first these vertical forces which are parallel to each other, but they are opposite in direction. क्योंकि इक्विलिब्रियम कंसिडर किया है, this means vertical components और horizontal components एक दूसरे ਨੂੰ equally ते oppositely match कर रहे हैं. So, Fg is t sin 80 here, means t sin 80 is 0.08, then you can find out the tension, and Fe is t cos 80, Fe is t cos 80, t ਦੀ value पता लग गई है ਸਾਨੂੰ 0.081. You want to find out the charge on these balls. You know electrostatic force is k into q square upon r square. So, 0.104 square, t is 0.081 cos 80 degrees. Use the values, use the value of k to be 9 into 10 to the power 9, you get q to be 1.3 into 10 to the power minus 7 Coulomb. Now, what is electric flux? You know that electric flux through any surface A is given by the dot product of electric field and area. Dot product, you know, it is E A cos theta, magnitude will be given by E A cos theta, where what is A? A is a vector which is normal to the surface, theta is the angle between electric field and the area. So, what does flux do? Basically, flux measures the number of electric field lines that pass through the surface. Electric flux depends how much strong the electric field is there, and on the relative orientation of the electric field and the surface, means what is the angle between electric field and the surface. Here it is normal to the surface, magnitude is A. If the surface is curved or the field varies, then what we do? We divide the surface into small regions with area dA, and then you know what is the small flux d phi given by E dA cos theta. To calculate the total flux, we integrate over the surface A. So, you use integral of E dot dA. If it is a closed surface, the loop means the integral is over the closed surface. Now, what does Gauss law explain then? Gauss law states that electric flux through any closed surface is equal to 1 over epsilon naught times the total charge enclosed by that closed surface. अगर ਤੁਹਾਡੇ ਕੋਲੇ कोई closed surface है, उस closed surface ਦੇ ਵਿੱਚ कोई charge q है, तो electric flux कितनी होएगी? 1 by epsilon naught times the total charge. So, you get the total flux within the closed surface, it is proportional to the enclosed charge. Now, when is Gauss law used? It is useful only when the electric field is constant on a given surface. So, how do you calculate it? Basically, you select the Gauss surface. In this case, it is this pillbox. Find out the flux of the electric field through the Gauss surface, equate it to the equation q upon epsilon naught, and you can find out the electric field. It is simple. Use the definition of Gauss law. use the definition of flux. If we have a spherical surface, this is because of point or spherical symmetric surface. In that case, charge density depends only on radial distance from the central point. Gaussian surface कितना ना होएगा जो point charge या spherical surface है, spherical